So it is now 10:30, guys, and we're about to kick off session 2. If you're just joining us, my name is James Bagley with Corteva Agriscience. I've been on the MABA board for around a year now. I've been working between BASF and Corteva Agriscience for about a decade in the state of Montana. Thanks for participating in the MABA Great Ag Rally. This is going to be another great series of 1-hour sessions. Help you stay informed with what's new in agriculture. Today, with our second session with Tom Wolf, it's going to be a very exciting one. We are going to have FEI to the sponsor. So I want to shout out and thank FEI for their sponsorship of this session. So I think we're going to start out with a sponsor video, and then Ben's going to take over and do a presentation. Off to you.
Thank you very much. Hey, I appreciate everybody's participation in this. FEI is, if you're not familiar with us, we are a 40-year-old fertilizer equipment provider. We provide liquid, dry, and anhydrous equipment for the industry. We have created a new partnership with Doyle, a family-owned company that has been around and one of the key leaders in the dry fertilizer equipment business, as well as another company, Mother Bins, that are a walkabout 4,000 bushel grain bin to make it more efficient for you out in the field and have less people waiting and sitting in drive time. And with that, we'll take a look at a couple of videos, starting with the Mother Bin and what it can do for you, and then we'll follow that up with the Doyle videos. So take it away.
Introducing the all-new Doyle AutoBatch, a fully automated blend system. This is a legal for trade, fully automated blend system, which means there is no expensive truck scale needed. Efficiency is gained by not weighing in and out, sometimes requiring additional staff. The high-speed direct drive rotary drum with a 24-inch internal mixing auger gives a quality blend in just 10 seconds per ton. With 36-inch conveyors, the system can load product direct over 400 tons per hour. Gain maximum efficiency by being able to have 13 to 16 tons of blended product ready to load as soon as the truck pulls under the loadout. This allows the system to load 24 tons in just minutes. For off-season or specialty blends, the hand-add hopper can be used as a traditional batch blend, which means product doesn't need to be added to multiple hoppers to do a single blend. Individual products are added to each hopper. The system will automatically dispense the required amount to create a blend. The 3-light system makes it easy for the controller to operate the system, which can also be done directly from a user-friendly handheld tablet. The 9-ton micronutrient hopper can be divided into either 2 or 4 separate hoppers, saving the cost of multiple hoppers for each micronutrient. In the event of a computer or software issue, the system can be operated manually with the easy-to-use touchscreen, eliminating downtime. Chemical treatment can be added to the mix with our automation program, using legal for trade scales for accuracy. Our automation programs provide in-depth management tools that will save hours of repetitive data entry and load scheduling tasks. This system has capabilities to integrate with over 70 agronomy and accounting software programs, making for an absolute game changer. The Doyle AutoBatch, another quality Doyle product.
So thank you for taking some time to look at those videos. If you want any more information about that or want to contact FEI, many of you already have our numbers, but I can be reached at 800-437-9702. Again, that number is 800-437-9702. If you've got any additional questions, just feel free to give FEI a call or myself, and have a great meeting.
Thank you, FEI. Those videos were outstanding. Thanks for the sponsorship. For those of you that didn't join us, we're going to have Tom Wolf again, sprayer technology preview for 2021, what's hot and what's not. So some new technology options out there reviewed by Tom. Tom Wolf is based in Saskatoon, Saskatchewan. He's over 30 years experience in the spraying business. He's got his bachelor's in science and master's in science in plant science at the University of Manitoba, and his Ph.D. in agronomy from the Ohio State University. Tom focuses on practical advice that is research-based to improve the efficiency of producers. And he also rides a unicycle to the office on most days. So Tom, we're excited to have you take it away.
Great. Thank you so much for the introduction, James. I'm really looking forward to this little talk about what I did here is I try to bring some of my views into it, the philosophy of spraying and what's important. And there's some highlights there, some technology highlights and some trends that we should be on the lookout for, and that maybe we could even advocate for as an industry, because sometimes we just have to communicate our needs to the people that make the products, and for them to be able to deliver that product. If we're silent about it, nothing much will happen. So I'm going to share my screen and move forward with that. So here it is. I hope you can see that. I see Ben nodding. That's good. I want to thank the Montana Ag Business Association for the invitation. Luke Diggins is my contact at the co-op in Scobie, and appreciate his giving me this opportunity. We have a website called sprayers101.com. I'm not going to say anything about it except that it's a resource for you. And a lot of what I'll say is on that website. I might make one reference to it in a few minutes. The fundamental principle is that a lot of the action in spraying is found while not spraying. It's a little bit like that grain cart video we saw. the productivity increase that the unloading and the buffering that a grain cart gives you, especially a big one, in terms of taking the pressure off the truck and keeping the combine running, has been transformative. And there's really nothing like it. You don't need a bigger combine, you need a better grain cart, and oftentimes to get more work done. I remember when I was growing up on the farm, not combining when the weather was good was the ultimate sin. But in the spraying world, it's a very common thing. For example, if we look at this pie chart, this is from JD Link. We look at this pie chart, we can see that about a third of the time we're idling. That's like waiting for the truck to show up. That's excruciating. What are we doing when we're idling? We're probably cleaning, we're probably tendering, we're probably repairing. But it's probably a spray day. Otherwise, that thing wouldn't be running. We spend quite a bit of time transporting. We're moving from field to field. It takes a quarter of the time in this example, and less than half the time in this example is spent spraying. So those are 8 R4045s. Those are pretty good engine hours per year. So, that could be a 5,000, 10,000 acre kind of an operation. And let me tell you, the numbers actually get worse than that. This is actually a pretty good set, but European numbers where they spend even more time cleaning and transporting are much lower in terms of actual productivity. This is a loss. So this is not just the ability to get the work done on time. It's also a loss in terms of yield loss. If you are not able to do that field before the rain, that's yield loss. So it's again a question of timeliness. So what's really hot and has been for some time is smart tender systems, and we're seeing continued evolution of those. And one new one that came on the scene in southern Manitoba is the Dash system, the fiber Dash. So this is a farmer-owned company designed by farmers and tested on their farm. They've brought some great innovation to it, and each of them has their own approach. Just a few of the things that we're looking for in a good tender system is, of course, capacity. So some people have a hot mix capacity as well, and I'm not sure if this one does, but we are looking for these kinds of things. The tanks should be black so that they don't get algal growth. A 3-inch pump is essential. I mean, there's even some people are moving to bigger pumps. Certainly filling these tanks, I've seen 5-inch pumps. These are 1,000-gallon-a-minute pumps. And why? Because filling 5,000 gallons of water takes maybe an hour or two, right? It could take a long time. So you are basically minimizing that downtime. Hose reel, the hoses get heavy. If you can't suck them empty or blow them out, an inductor. Basically, most of my customers have gone away from product pumps to inductors because of the speed. Now, product pumps are catching back up. We're seeing some pneumatic pumps that are doing 20, 30 gallons a minute. That's important, and I think that'll help. But if you're sucking from a toad on a cold day, you can't afford to wait 25 minutes for those for that product to get into your tank. So inductors solve that problem. We're seeing manifolds, so drawing from different totes, doing your tank mix is nice just with a toggle of a switch. Those are the basic things we see. And this one, we see the cage. So you put your empties in there, they won't blow away, all kinds of things. You've got some ramps here for the quad, all kinds of cool stuff. I've seen some that are doing a B train on the end here. So they're actually able to unhitch their inductor setup, or perhaps even come back with a tote from the rear. Oftentimes they're side loaded. Sometimes you don't have the room. So coming at it from that other side is a cool thing. This is Doug Applegate. I just wanted to give him a shout out. So Doug and I talk frequently. He has a system called the MixMate. His company's called Praxidin. So he's a thinker. He's innovative. He's got some very thoughtful flow meters, and he's even got a load cell on his inductor here. So in automatic record keeping. So there's continued evolution here. What are we trying to achieve is a safe mix that doesn't gum up in the tank, complete dissolution, solution, and also you want to be able to do it in less than 10 minutes, if at all possible, So a hot mix might only take 4 minutes to pump over, and that's what we're trying to achieve. When you're filling every 25 minutes, in some cases, it depends on the size of the tank and so on, that is a big deal. So your mixing time. So we have articles on Spurs 101 about different setups, what guys are doing, the kind of innovation they're bringing to the field. So that's definitely a hot technology, continues to evolve. That's where the action is. What's hot? Water-sensitive paper. How long has it been around? Generations. Is it cool? Absolutely. It lets you see what the spray is doing. We talked about it a minute ago. I promised now to get you a little more detail. So this is what a bag of it looks like. It's made by Syngenta, actually, and it's sold by TJet and Hypro and Williger and whoever else sells nozzles. Sometimes chemical companies will give it away as well. It comes in these boxes. You get these apps now. This app that we use is called Snapcard. It's from Australia. Basically, what you're doing is you're taking a picture of the exposed water-sensitive paper. On the right here, you got these handles you can drag to the region of interest, and it tells you at the bottom right away. It tells you coverage. It doesn't tell you droplet size, but it gives you a hard number, and you're integrating that with your own visual observations and your experience. Another one that gives you more numbers, if you're more into the research side of it and you want some more information, is something called Dropscope. We got this one from Brazil. It plugs into a USB port of a laptop. Since we bought it, they've come up with a Bluetooth version, so all you need is a smartphone. But it's a very high-res scanner, so it actually is designed to fit these water-sensitive papers directly into the scanner, and it gives you terrific output. So if you're a numbers nerd like I am, you get distributions of diameters and volume and quantity. You get all kinds of hard numbers in terms of number of drops, the variability. It does some volume median diameter work, and so on and so forth. It writes reports for you. It's a very, very cool piece of hardware and software. So if you're repping a company and you're doing some low drift work and you want to just document where the spray goes in the canopy, these two tools are my recommendation for making that powerful. And then you can actually do statistics on it. And rather than saying, which one do you think is better? You can actually say, well, this one's 25% better. What does that mean? Another technology that's super hot is optical spot spraying. So we see a lot of different, well, not a lot, but we see an increasing number of entrants into this. And I'll try to cover as much ground as I can here. The one we're looking at is the third generation of a product called Weed It. And Weed It is available in Montana. They now have the fourth generation. We'll show a picture of it in a second. Basically, what this is it's a sensor that finds a plant, a green plant that does photosynthesis on a non-green background on bare soil. So it's a pre-seed burn-off, post-harvest kind of a thing. And basically, it's able to see weeds as small as these little fellas here, this little red root pigweed. And we just use paper to see, did the nozzle go on? Did that thing get sprayed? And the answer is absolutely. Here's a little video. It's a bit of a compilation of a couple of videos I caught on the web that I thought were the best at doing it. This thing will go up to 12 miles an hour. Sometimes people have used it at 15 miles an hour. It senses the plant and basically activates the nozzles that are just there. The older version had the red light. The new ones have a blue light. It's a lower power consuming light. These sensors are spaced at 1 meter, 40-inch spacing, and they activate 4 nozzles. So it's a high-res thing. The nozzles, as you see, have narrow angles here. They're also pulse width modulated. We talked about that at the last talk. If you weren't there, that means that the flow rate is adjusted for travel speed with a little pulse. So this is the new generation here. This is a picture from Europe or video. They're going pretty slow, but the visual is pretty strong. It only sprays the weeds. What are you getting? A lot of savings. I wanted to show you this one because you can tell every nozzle's on, but you still get the spot spray. It has something called a background mode where you, I think it's called dual mode actually, where if your weeds are so small that you're afraid you can't see them, the sensors can't pick them up, and there is a threshold limit. It's maybe a thumb size or something. If they're smaller than that and you need to get them, you can turn the entire boom on, but because it has a pulse width modulated nozzle valve, it will allow you to select the actual rate that you want to apply. If you got a tank and you got the full quart of product in that per acre, you might think that, hey, the tiniest weeds will die with, say, a quarter of that, because they're the smallest weeds. They don't need the full dose. So you can put your whole boom on at quarter label, and then when a bigger weed comes on that won't die with a quarter label, then it still is sensed by the sensor, and the whole thing, the whole spray comes on at that nozzle. So in our experience, these things are saving somewhere between 50 and 75% of the spray on a burn off. And we're going to get back to what that really means. The new Quadro has a green housing with a blue light. It's a little bit more compact. It's more power efficient, and they now go on a 10-inch spacing. So you get 4 channels per sensor. So you can go on a 10-inch or a 20-inch boom setup. All you need is the extra nozzle location in there, and that is part of the kit. Nice thing about the Quadro is that it is also, when not sensing, a full-blown pulse width modulated boom. So turn compensation, rate adjustments for travel speed without change of pressure. So a very sweet setup. I wanted to just maybe take a step back. There are some competitors to this. We do need to mention them. Trimble has a system that you probably have heard of. It's called the Green Seeker. Well, it started off its life as the Weed Seeker, and it's the same NDVI technology, and they've had a second generation of product. It is slightly less sophisticated than this one. It's slightly less fast. It doesn't have multiple channels, so you need one sensor for every nozzle. So the really high resolution isn't possible. The high savings aren't possible, those kinds of things. And it's also not pulse width modulated. And the other ones that are around the corner are really just regular camera systems. And they basically use just an RGB camera, and they say this is a weed because it's green, and this is not a weed because it's not green. They don't have a fancy sensor. So they're able to do that. They might be even using shape recognition to validate the identification. We're going to get into the green on green version of that technology a little bit later on. What's cool about this whole technology is that it gives rise to new ideas. This is Andrew Guzomi, and he is a scientist at the University of Western Australia in Australia near Perth. And he's developed this thing called the weed chipper. What he found was the weeded sensor and said, I don't know, maybe we can do something with it. What do we got here? We have a spot cultivator. So the shanks are up. They're spring loaded though. Whenever it sees a weed, it hoes it out. So that's a good tool for us on the arid Great Plains of North America, where we're trying to reduce tillage, but sometimes you still need it. And you can do basically spot tillage. So I love this. I think this is a great little innovation, and who knows what else is coming down that pipe. So that's green on brown sensing. It's available. It's on the market. The technology is called Weedit. It's available in Montana. It's expensive, but before we get out of it, I just want to make this one comment. We're not going to talk about herbicide resistance except now. Herbicide resistance is an ever-present threat. We've got kochia in Montana. We got other weeds on the way. I hope not soon, but that corner of the world is one of the last places where we don't have palm or amaranth yet and those kinds of weeds. In order to delay the onset of resistance, the most powerful herbicidal strategy is multiple effective modes of action. And what that really means is tank mixing, so that you have more than just the group 9 that kills your burn off, but also maybe a group 6 or a group 14 or a group 15, kind of, the FMC new farm products that are out there. Other modes of action are, specifically designed for that burn off that is effective on the weeds you're trying to control and will kill the resistant biotypes. That is expensive. And saving 75% of your spray makes it affordable. If you're covering, let's just say for ease of calculations, if you're covering 10,000 acres and you've got, a tank mix that's worth $10. Okay, it's a multiple effective mode of action tank mix. It's $100,000 you're burning on burn off. If you can save, let's just say 50% of that on the burn off, that's a $50,000 saving. That's now a $5 per acre treatment. That's now affordable. That means that you have just implemented a tool that gives you multiple effective modes of action that will delay, it won't prevent, but it will delay the onset of resistance. And we want to do that as much as possible. So that's the only thing I'll say about that. It's an agronomic tool for the long term. What's hot? Our mesonets. So this is just to the east of Montana. This is North Dakota. They have one of the hottest mesonets in the country. It's the envy. I mean, I wish we had this in Manitoba and Saskatchewan, where I'm from. We don't. They've got probably close to 100 of these sites. It's called NDON. It gives you temperature, precip, wind speed. It gives you temperature inversions not on all of the sensors. It gives you some high level temperature inversion. They have some 10-foot high sensors. Really amazing utility of this. And this just gives you better ability to monitor the weather conditions at the locations. It might be a very good tool for scheduling spray systems and so on. This is also available through Farmer's Edge. It's available through Climate Field View, where we're putting these weather stations. And just to give you one example, this one happens to be from Melfort, where we've got some inversion stuff. I wasn't able to do the screenshot in time here for the end on, but it gives you upper and lower temperature, and it tells you the inversion potential is very low. But if you have a different kind of temperature situation here, much greater difference, a much colder, lower temperature, you have a high inversion potential. And that might tell you, I'm going to have to wait an hour before I spray. I'm going to have the sun come out and be sure that we have good conditions for that spray to not go awry. So fully supportive of these mesonets, very, very powerful tool. What's hot are stable booms. And this is a bit of a bee in my bonnet, as I said an hour ago. I wish that for the $500,000 that a sprayer costs, we can get a boom that is consistently 20 inches above the target over our terrain at our travel speeds. And that would help a lot with uniformity. That would help a lot with drift. It would simply be a very useful innovation. We have not got this boom in North America. We have aftermarket companies that are coming in. They're improving the situation, but their hands are tied by the auto boom systems, the center rack configuration, and so on. The European imports that we're starting to see, this is a picture of a horse, which has a low boom philosophy and is advanced. So we might be able to see it. A couple of years ago, I went to Germany, and this is the Amazon, and this is Timo here in the middle here, and he just jumped on the boom, on the bumpy track, and the boom said, "I don't care." And they actually drove, and he just held on, and they went over the bumpy track together. And the boom said, "I don't care that there's a guy, on the left side. I'm going to be okay with it." And these bumpy tracks aren't necessarily what a field will look like, but they're a nice way of making sure you don't have boom sway and boom yaw. And their engineering approach is to minimize that, and they're advertising for it. They're saying our boom is stable, our boom does not whip, and that's what we need. Okay, that's a very important feature in boom. So that's hot, and I wish it were here. But I think what that really means is we're going to continue to see European sprayers like the AgriFac and others coming in and basically taking that niche and saying, we can do this. And with the sprayers being as expensive as that they are, any additional feature that you can get, I think will have some value. Here's another European innovation. This is a Bertude joystick. I'm holding it. I ripped it out of the cab. Basically, it becomes a remote control, and you can take it to the boom. You can change your spray pressure. You can turn your boom sections on and off. What a great idea. I mean, I wouldn't own a sprayer without a remote control sectional controller for priming, for flushing, for checking. It's just an essential tool. These guys are building it in, and they're saying, we got it, we got you covered. So that's an absolutely essential piece of equipment for me. So this is just one example here of a company doing it, but of course the aftermarket ones are for now absolutely indispensable. What's not hot, I'm just going to maybe give you 2 examples of what I think is not hot. What's not hot is monitors. I'm not picking on anyone. Everyone's equally to blame. That you have to have a half-hour tutorial on before you can spray. I sometimes say the golden age of the monitor was when we had toggle switches for power, pump, sectional control, and pressure up and pressure down. And that did the job. We had to punch in our gallons, but once we went to a system that gave us basically everything that you could possibly dream of, and then decide to give it to you on a screen, the icons became smaller, and hunting for that one thing you wanted to do became a long-term exercise. In some cases, you have to develop an A/B line before it'll actually turn the boom on, unless you know how to override that. These are things. If I can't do it out of the starting gate, then maybe it's too complicated. What I'd like to see is kind of an ergonomic approach, a user-friendly approach, maybe a basic level, and just say, look, today I just want my new staff person to spray this field. I just want the basic level of menu options. I want gallons per acre. I want to be able to rinse the boom or prime it. And I don't need the other features right now because my sensitivities and all that stuff are set in. Wouldn't that be a wonderful thing? So I'll leave it at that. What's also hot are drones. Drones are on their way. The evolution of drone technology is rapid. Anyone can buy a drone like this. It's a 25 kilo version of a drone with a 15-liter tank. It's an octocopter. They're affordable. They'll spot spray. They'll do niches. They're not yet legal everywhere. They're not legal anywhere in Canada, but some states have allowed them to be legal. The EPA is still on the fence. They have allowed states to give permission to use them. But we really need registrants to come on stream as well and make sure that their products are going to be legally applied by drone, because there is an issue with spray drift. But there's a rapid evolution. This is a drone I saw a couple of years back. It's from a small company in Kitchener, Ontario, and it's called Advanced Robotics, and they have a hybrid. So it has, 2 rotors that are vertical and 2 that are not, and they rotate actually. And so you got lift and propulsion. You got fixed wings, so at high speed, and you got a full boom. You got high payload. So these are the kinds of drones that you can no longer just buy off the shelf and fly yourself, because they need an advanced drone operator license. In Canada and the US, the 25 kilo weight limit, below that, you can get a basic license. I've got it. It wasn't that hard to get, and you can do whatever you need to do with it. But these heavier drones require advanced license, special flight certificates. And perhaps that means that professionals will come in. Perhaps this will be a contracted service. But it's already legal to fly them in swarm formation. It's already legal to have up to 5 drones visual line of sight in Canada spraying simultaneously. So then it becomes really a question of tendering, logistics of that. But these will come in. We do have working groups. There's an OECD working group. There's a North America-wide working group that I'm a part of. We meet monthly. We talk about what we need. And the regulators are saying we need drift data. We need efficacy data. And everyone's basically of one mind, saying we cannot really allow a high drift drone because it will basically ruin it for everyone. Drift is still a very important concern for the EPA, for the states, and as well as for the Canadian jurisdictions, and they will have to do that. They will be able to do that with higher capacity. Higher water volumes allow you to use coarser sprays, and will develop the drift work and do the proper risk assessments. So hopefully the industry will join this venture. It's an exciting time. Lots of new technologies coming here. Machine learning is absolutely hot. This is huge. I'm working with a couple of startups that are able to see weeds and identify them by species in 50 milliseconds. They basically need a high res video image of it. I'm just going to show you a little video of this group here. This is a company called Green Eye, and they basically fly low drones over the field. They don't cover the whole field because of the resolution needed. So they'll take a picture that gives you sub-millimeter pixels. And then what they can do is they can basically tell you where the species are. So they're saying amaranthus, that's pigweed. They're saying that's the heat map for it. And they're going there and they're saying, okay, it's pretty hot here. What do we got? That's the field. What is oh yeah, that's what it looks like. And they've identified every plant by species. So there's, they even identify rocks. Then what they do is they basically will give you a pie chart, a table. They'll tell you small leaves, large leaves, and they'll give you the distribution. This is like now you have a map of your field. Where are your weeds and how big are they? Even just for scouting, that's powerful. And maybe monitoring the effectiveness of your herbicide program, taking note of areas where resistance might be emerging because you haven't got effectiveness, and being able to do a ground truthing on those. So that's Green Eye. A company called Tyrannus is also doing the same thing. They're still struggling with a high res complete field coverage because they do have to fly low and take essentially a sharp picture. And that's a challenge. But the artificial intelligence is there. And what they're trying to do is develop these sprays so that we can get cameras on booms, be able to basically speciate every single plant that's on the field, and then say, all right, we're going to spray this one, but not that one. We are at about an 80% success rate, judging by the companies. Zarvio is leading the field. So a few others are in the game. Carbon Bee, Bilberry are doing it in France and Australia, respectively. Both of those are French companies. And we're starting to see that kind of technology. So the future is bright. We're going to see Blue River, of course, is one from California. We're initially going to see this roll out in the row crop world. So it's a little bit more of a eastern Great Plains, southern area, not so much in Montana where row crops are a little bit more scarce. But what they will do is they will point the camera between the rows of, say, the corn or the beans, and they will say, if I see a plant in there and I know for sure it's not a bean or a corn, and those are pretty easy to identify, I'm going to assume it's a weed. Even if I don't know which weed it is, I'm going to activate a nozzle and spray it. So it's essentially green on green, speciating and making a decision on that basis. And then from that point, we'll get incrementally better at doing this, and we'll go to narrower row spacings, and we'll go to other crops. And then eventually the most difficult part is, of course, the shaded weeds, the weeds that have been driven on, the ones that are covered by trash. Those are the ones that we'll then be able to detect more accurately. Big challenge, but I think their threshold for making this work is about I guess the kind of performance we want from herbicides. We're expecting a 95% success rate with herbicides. Otherwise, we may need to spray again, depending on the weed density. Well, this technology is going to have to be the same at the same level. Here's just one example of what they're doing, driving with the video camera and saying, yeah, that's live. So they're saying, yeah, we got stuff. This is what it is, and we're going to spray it. So very, very cool. We're going to change gear now and just talk about a little analysis we did recently, and then we're going to focus on 4 solutions to the problems we're going to find. And that's how we'll finish off. We still got a good 20 minutes or so to go here, but this is the change of pace. What I want to show you now is basically a chart here that talks about where the spray goes. And I'm going to give you some scenarios that you might not necessarily agree with, but they are a baseline, okay? My first baseline is our field is 160 acres. What that means is this is a unique herbicide on those 160 acres, okay? We're coming in with a cleaned out sprayer, and we're going to clean it when we're done, okay? We're doing 10 gallons. We got a 1,200 gallon tank. We get a 120 foot boom. Where does the spray go? So the total volume we need is 1,600. That's 160 times 10. But first thing we do is we have to prime the boom. So we have to fill the boom with about 30 to 40 or even more gallons of liquid to get all the hoses full of spray. And while we prime, we spray. And depending on how experienced the operator is and what features the sprayer has, some of that product will spray onto the ground. That's what we prime at the edge of the field, boom hanging over maybe a grassy area or something. And we accept the fact that some gallons are going to hit the ground here. How many? That's each individual has their own number. We will have overlap waste. Most of our sprayers are plumbed and sectional control is plumbed, and the outer sections are somewhere in the neighborhood of 10 feet. Depending on the squareness of your land, whether you got sloughs, coulees, trees, rock piles, you will have some overlap waste. The guys in southern Alberta, closest, coulee country near Lethbridge, closest to Montana, I have heard 4 to 5% overlap waste on a traditional plumbed system. So that's what I'm putting in here. That's 64 gallons. When you're done, your tank might not be completely empty. Your pump will have drawn air before it's empty, and you may not have calculated accurately and maybe erred on the side of caution. You may have 60 gallons left over. You now have to push all of the product that is in that boom onto the ground, basically. You're meant to drive through and pump that boom empty with water to purge or air purge it. You're going to push all the stuff you primed with out onto the ground. You might be drifting a little bit. We're assuming a 2% drift is not so much, but it adds up. This is admittedly a worst case. We're talking about putting 228 gallons onto the ground, basically, or losing it. And we're essentially, going to put not 1,600 gallons in that tank, but maybe 1,750. And that's 14% waste. So what can we do here? Let's do one more scenario. Let's go to the burn off, the 5 gallon. So the numbers are essentially the same, okay? Our priming waste is still the same number of gallons, but because the concentration is much higher, it represents a higher percent. Overlaps the same, but again, clean out and tank and boom clean out are much more harmful because they represent a more concentrated solution. And basically, we're talking about we're losing less gallons, but they're more valuable, and that's a 20% and change loss. Okay. Now let's implement some good technology. We're back to the quarter with 10 gallons, 1,600 gallons. We're going to put a recirculating boom on here that offers no priming waste. We're going to put individual nozzle sectional control on that reduces overlap waste to 1%. We're going to have a better tank. We're going to have more accurate volume measurements and a better sump in that tank. Boom cleanout waste is still the same because it has to leave the boom, go onto the ground. We're going to put a low drift nozzle on, and our total loss is 92 gallons, is only 6% from 15. Okay, so that's what ultimately we'll have to do. Now, I accept that doing it on the quarter is maybe not that accurate. Let's say you can do 1,000 acres between cleanouts. Okay, and let's say you've got the good plumbing that we talked about. So you're doing 10,000 gallons. You're not losing anything to the prime because you got a recirculating boom. You've got overlap waste of 1%. You've got individual nozzle sections. You've got tank cleanout waste, 12 gallons, so very, very little. You still have the boom cleanout. That stuff still has to get pushed out. You've got to get rid of it, so that's gone. You've got a low drift nozzle, but you can reduce your total loss to 2.6%. That's from 14. And, we can run all kinds of scenarios. We have published an article on this on Sprayers 101. The spreadsheet that I'm using here, it's on there. You just hit a button, it downloads it automatically to your downloads folder, and then you can play with your own numbers. But what an eye-opener to me personally about how large these numbers actually are. So now I've identified a few technologies that I now want to highlight. And I've mentioned the recirculating boom. Okay, what is it? So a telltale sign is rather than have a boom end here, the end is open and goes back to the tank. Okay, for those of you not familiar with plumbing, basically a conventional sprayer is plumbed the following way. you have a tank and a pump. The pump pressurizes the liquid. There's some bypass for pressure control, but it pushes it basically to the boom sections. And these sections are maybe 10 foot in length. And these are your sectional controls. So you can individually turn these on or off depending on what you need, but they have boom ends. So at the end here, you get a very slow migration of material. You might have a dead space here. You might have sedimentation of dry material. You have a problem area. It looks like this. So here's your boom end. This area doesn't get flushed out easily. So you have to remove this cap, and some people put, elbows and banjos on here to do that. It's a little bit of a messy operation. You can get, these Hypro Express nozzle body end caps, which have been a great innovation for that. John Deere also has those. And but they've even found with those that they actually do have some settling. So they actually then developed an add-on that lets you drain them temporarily. So even that wasn't done away with. So it's a bit of a pain. A recirculating boom addresses this issue by having the same tank and pump, but now pushing the liquid not to the middle of the section, but to its end, and then flushing it all the way through and then coming back to the tank. Okay, so that is the principle. And the idea is that you get an entire left and entire right section of boom, and the nozzles, the sectional control, are now with individual shutoff valves, just like we would have on a pulse width modulation system. Okay, couple of systems use a three-way valve here, so they can actually choose to push to the end and then bring it back to the tank, or they can open this valve up and push it to the boom both ways. So this makes clean out easier because you can push your pesticide that you have to get rid of onto the field this way, and then only this little section here would go back to the tank, or basically it gets a drain valve and goes on the ground. So that's the principle. Back to pictures. This is the first commercially available recirculating boom in North America. It's the Rogator Liquid Logic on their C series. Very nicely engineered, quite complex, but it works. Nice sweeps, and it's integrated into their monitor system. So this is an option. This is the Palmier boom. This is the boom that actually brought this technology to North America some 15 years ago. So they will pump the spray to using this steel line. This is from the tank, and comes around and goes into the boom, and then goes back towards the tank from here, and then has individual shutoffs. In this case, the shutoffs are air activated, so they're not that expensive. Aftermarket, this fall, Raven introduced their aftermarket system. It comes with a kit. It's about, I'll have to see what it is in US dollars, but it's let's say around 5,000 is what I've heard. I think it'll be a little bit less than that in some cases. What they're doing is they're taking individual plumb sections with their individual sectional valves, and they're actually just stringing them together. They're just saying, we're going to push the liquid to the outside, going to come in here, and then we're going to go to the middle, to the middle, to the middle. We're going to push it, this is the center rack here, we're going to push to the middle, go to the outside, and then all of these will ultimately then come back to the tank. So it's a retrofit. You don't have to change your booms per se, but you do string the individual sections together. The nice thing about the Raven is it's ISO-bus. So it'll go into your Viper 4 or any other ISO-bus terminal. So that's kind of sweet. We have a little Canadian retailer called Nozzle Ninja, cut his teeth in the sprayer business, and he's working with AREG. And he's working with AREG Australia, actually. So AREG's Italian, but they provide actually a lot of behind-the-scenes material for North America, too. They developed a recirculating aftermarket kit. And I just talked to Mike Wengren yesterday about this and how it's going, and it's selling very well. So it's, again, an aftermarket. It comes with its own monitor. Okay, so now it's not ISO-bus, you're not integrating into something else. You toggle a switch when you want it to recirculate. So the big advantage here is the following. If you wanted to prime that boom, okay, you would leave all your nozzles off, and you would simply push liquid to the end and all the way through and back to the tank, and you would push the product through. And if there's a plug of water, that would just go back to the tank. No big deal. And then you've not sprayed a gallon and your boom is fully primed and you can go. If you wanted to, depending on the configuration of the sprayer, if you wanted to flush water through this boom without emptying your tank, say you want to keep going tomorrow, but you got a dry product, you want to get rid of it in the boom, you can draw water from the washdown tank and push it through the boom and push that plug of dirty material mix back into your solution tank. And not every sprayer will let you do that, but that's one of the nice features about it. So very sweet. So that's recirculating booms. We've written an article on sprayers one about it if you want to read more. Continuous clean out. Cleaning out, I always jokingly ask my customers the question, when do you know that you're done cleaning your boom? And the answer is usually in about 2 weeks. Because you never know, because dirty water and clean water look and smell the same. It's a small amount of stuff. And so you're precautionary. It takes a lot of water, it takes a lot of time. Continuous cleanup is a way to make that less time consuming. And here's how it works. So you will buy a second pump. This pump will be dedicated to the clean water tank. Okay. And when you're spraying and you're spraying your tank empty and the pump sucks air, you will turn this pump on. And it will then introduce clean water into your tank via washdown nozzles, and the sump will fill again. Your solution pump will draw water again, and it will now, if you keep this sump volume very low, it will now, first of all, get rid of that plug of tank mix that will continue to dilute in this system. It's a logarithmic dilution. By the time your clean water tank is empty, if you've done this right and kept the sump low, just starving the solution pump, you will have a system that is made of water. How long did that take you? 5 minutes. Did you leave the cab? No. Did you flick any switches? Yes, so you flicked the toggle switch in the cab. You kept on spraying. You're perhaps going over your headlands another time, whatever. That is the deal. Lots of guys are doing this. So this is one I visited at a John Deere dealer a couple of years back. He showed me his setup on a 4830, very clean. So he's using this pump. It's the AMT pump. It's a 1-horse. It looks like a starter motor. It draws a lot of amps, but it doesn't run very long. The 4830's batteries were able to handle it for the 5 or 10 minutes it runs. It does give you 35 gallons at 20 PSI, which is what you might need to wash that tank down. It does give you a higher flow, but at lower pressures. He put a pressure gauge on it so he knows what it's delivering. Here's his 4830 tank. He's got 2 of these inverted deflection cleaners. He said it's absolutely wet in there. It's just a shower. So he's happy. What he did then, though, is he introduced. Here's what you do. You're basically spraying your tank empty in the field. When you're done, you just keep going until the tank is completely empty. And when your pump sucks air, you flick that switch that turns that blue pump on. And you're delivering to that sump about the same volume as you're currently pumping out, let's say 30 gallons a minute. If you can't deliver 30, you slow down and you only deliver 20 or 15. It doesn't matter whether you have a good spray pattern. And you will just simply match those 2 flows. And then you will basically clean your tank. You will not have, you're diluting. You might still need to do extra cleaning, but the biggest work, the one that takes the most volume, the one that you dump material on the ground, that part's done. Okay. The key to it is the AccuVolume. The AccuVolume is a device exactly as big as I'm holding here in my hand. That is a pressure transducer. This gets plumbed in to the sump and it weighs the material in the tank. It gives you 1 gallon accuracy of your tank contents at any time, any slope position. As long as there's a water column putting pressure on this thing, it'll read gallons. And you calibrate it once, and then you know whether you have 500 or 50 gallons in your tank. If you have 47 in your tank, you'll know. This is a way now to more accurately fill and empty, make small adjustments to your last pass. If you're not going to be empty when you're done, increase your water volume by a gallon an acre, and make sure you are. You can monitor it. You're not counting down with a rate controller that you might not trust. You're actually measuring what's in there. So that's the key. You can bulkhead fit it in there. It just has to be in a space where there's no flow. And here is you get two of these little screens, one for filling, one for operating, and you know exactly what's in that tank at any given time. How much is that worth? Well, you got to use it to really appreciate it. These kinds of things are on the website. You recognize some of the graphics. So if you Google continuous rinsing or recirculating boom in their search bar on the top right corner, you'll get articles. There's no advertising on our site. We talked about PWM this morning. For those of you that are joining us for the first time, pulse width modulation is a system of controlling the flow rate of a nozzle without a change in spray pressure. What it does is it intermittently interrupts the flow to a nozzle, and that interruption is adjustable, and that's called pulse width modulation. It allows you to adjust the pulse width of that interruption. The proportion of time that the nozzle is off is called the duty cycle. And you are now basically spraying sort of like this. If it was showing better, it'd be better, but it might yet show. This is a bit of a slow-mo, and you can see that it's pulsing intermittently left, right, left, right, left, right. I'm going to go through this because I don't think it's working well. Other manufacturers like Greeneye, like Agrifac, are producing these solenoids. They're not difficult. This is the poppet. There's a magnet in here. This thing is spring-loaded. It seals against the flow orifice, and basically it just pulses back and forth. So it takes a few amps to do this, but not a huge deal. Here's the Agrifac one. And what you get with it automatically is sectional control resolution, which is very cool. But you also get the other things we talked about this morning, like turn compensation and so on. This is going to set you back some coin. These things are coming in at 20 to 40,000, not cheap. But just the sectional control by itself, if you can assume a certain amount of overlap loss on your field, that is something you can very quickly figure out your ROI. Typically, the ROI on sectional control alone is only a few years. So, and then it gives you, the turn comp and some of the other peace of mind features as well. So that is absolutely going to continue to grow. I talked to John Deere at the last, in-person meeting I was at. I asked them how much of your throughput is selling with ExactApply, the John Deere version of it. And they said their estimate right now in Western Canada is 80% of John Deere sprayers are going out the door with ExactApply. Case has been at close to 100% with Aim Command for years. And then almost every manufacturer offers it as an OEM option. Okay, what's hot is dicamba nozzles. Not because they provide great coverage. I mean, let's be honest, they're so coarse that they don't, but because they let you finish the job. So this happens to be a soft drop sold by Greenleaf out of Covington, Louisiana, great company. And this happens to be the Hypro ULDM, a new one that they've made, super wide fan ankle, super coarse. These are made for the dicamba market. I know that dicamba is not a big deal in Montana, and that's not my point. My point is you should have a nozzle like this. Why? Because it'll get you out of a tight spot. When you're 15 miles from home, the weather's turning bad and you got to finish, but it's getting windy and you're worried about your neighbor, put these nozzles on and finish that job. You can get done, and you might have a coverage loss, you might have an efficacy loss, but it is not going to be very serious. It won't be zero. You might have a 10 or 20% noticeable loss of efficacy, which is still good enough, still better than not spraying it at all. So this is, I think, this needs to be in your quiver, this kind of a tool. A huge selection of dicamba nozzles. Every nozzle manufacturer that I speak to is making dicamba nozzles and almost nothing else, And it's partly because of that XtendiMax revolution, but also for us, I think. That, ladies and gentlemen, that is it. I want to thank you for the time. I think I've stopped sharing. I think that went automatic. I will turn it back now to James to see if there's any questions or any discussion, anything we want to talk about.
Yeah, outstanding information there, Tom. It's great to take a break from what we're in our daily grind and see what's happening in the marketplace. And that's some really excellent technology and kind of hints of what's to come in the future. So I appreciate that. If you guys have any questions at all, please hit that Q&A box. Tom's going to be around for a few more moments to answer those. You know, guys, if there are no other questions for Tom, I'm going to have to thank everyone for joining us in the Ag Rally. We hope you found this session to be valuable. I know I certainly did. Thank you to Corteva, FEI, and also Tom for their support at MABA. The next session is going to be held February 16th, 2021. Oh, looks like we have a Q&A. Let's see if I can't get to that. Okay. This is from Christopher, could you tell us 3 must-have nozzles on the sprayer? And what a loaded question for Tom.
Yeah, but it's a great question. I mean, here's where I go. I think that everybody should have basically a low drift version of whatever, right? And I think we already actually do. And I am not fussy about manufacturers. I'm going to list them. I'm going to read them off. So if you want to write this down, I'll actually list brand names in alphabetical order. Okay. Something that might be creeping down into northern Montana is the air bubble jet. It's a Southern Alberta nozzle. It's made in the UK. It's great. It gives you a coarse spray. It's a low pressure air induction tip. Okay. Next one is the Greenleaf Air Mix. Greenleaf, as I mentioned already, common in Louisiana. That's actually a German nozzle called Agrotop. The Air Mix, great low drift spray also, a little bit coarser than the air bubble jet. Next one is the Hypro Guardian Air. The Hypro Guardian Air is basically the same version, but it's just made by Hypro. So these are running 30 to 90 PSI, that kind of thing, coarse spray quality. Fourth one is the T-Jet AIXR. I talked about it earlier today. That's the same basic version of the nozzle. If you're pulse width modulated, then you would be looking at the Wilger nozzles, and you'd be looking at the Wilger MR and SR. And those are my go-to do everything nozzle. They all produce a similar spray quality. Okay, so you go to the manufacturer that you want. Leckler makes a ceramic version of it through Hypro. And you would just size them for your 5-gallon work, your 10-gallon work, and if you're doing fungicides or desiccation, your 15-gallon work or 20-gallon work, and use the same one. Just the same model, just in a different size. Those are the go-to nozzles. Then everything after that is niche. Okay, so if you're doing if you're spraying scab on your spring wheat or your winter wheat or your durum, and you want to get a scab nozzle, you would then go into a Fusarium head blight. You would then go into a twin nozzle, for example. And so those are the kinds of things. But other than that, we're good here. So hopefully I answered your question, Christian.
Excellent question. Guys, if you have any more questions before we part ways with Tom, he's an excellent resource here. Okay, well, again, thanks everyone for attending. Our next session is going to be February 16th, and that one is going to be Nutrient Management and Oilseeds with Dr. Kent McVeigh out of the Southern Ag Research Center, and then Mental Health and Agriculture with a Ph.D. Allison Brennan. So 2 exciting topics in another 2 weeks here. Again, if you're not registered, go to mtagbiz.com, register for these sessions, and take advantage of the opportunity to see what's coming next. I want to thank everyone for joining today. Outstanding questions. Tom, thank you on behalf of MABA. Thank you on behalf of everyone here. You did an excellent job today in providing outstanding information. With that, I'm going to retire and wish everyone a wonderful rest of their day. Thank you.